Hi, I'm Daz, and another radio kit has arrived. I must be a glutton for punishment. This looks nicely wrapped. This one is a discrete FM radio. So this looks like this could be a bit of fun. No ICs in here, conventional IF stages, so yeah, looks like this could be a bit of fun. Well, that's a bit different, look at that. Components actually taped to a bomb list. That's nice. I do like that. And yeah, that's good. I like that. It should help to identify the cores a bit better. Certainly want to get them the right way round. Yeah, I like that. That's good. Some variable resistors, volume control, and some inductors. What's in here? Oh, there's a loudspeaker. Looks like something you might find in an LCTV, complete with mounting brackets. This kit, I haven't got any mounting hardware, so I guess we'll have to make my own. But yeah, certainly looks a bit of fun. Little Egg Tart, a full FM discrete FM radio. Yeah, okay. Exciting. First thing I'm going to do is just check the colours of the inductors. That's the most important thing, I guess. Okay, so I fitted all the resistors. Well, haven't. Unfortunately, in my kit, I've got some duplicates and incorrect resistors. I'm missing 3 470 ohm resistors and a 24k, so that's a bit of a disappointment, but I'll have a rummage in my resistor drawer and find the missing resistors. Just having a look at the 100 nuff, that's always a guide to me of how good the capacitors are. Yeah, okay, well, I've seen that before, so I'm not going to worry too much about it. They're just for decoupling. Yeah, I'm just looking at the 47s here and they're all pretty accurate. They're within 5%, so yeah, I think the lower value capacitors where it affects tuning is where you need the capacitors to be good. Well, I'm slowly moving along. The only thing I noticed is that the sheet, this brown sheet, had a couple of values on that are slightly different on the board and actually supplied, which was this 22 and 6 puff. In the local oscillator, I've put the transistors in. Had a bit of a fright when it looked like I hadn't got the right ones, but they were just in the wrong order, so fair enough. Obviously the transistors have to be put in the right order and in the right place, because some are designed for RF, some are designed for audio. You get an audio one in the RF stage and it isn't going to work, is it? So, but yeah, I guess the next thing I better put some diodes in. They need to be the right ones. Some RF ones here and some other diodes here. The bias. That's interesting. The circuit diagram appears to show that there's 3 diodes. I can only see 2. Well, it's a bit strange, but a nice looking output stage, I must admit. Just starting to put the electrolytics in. I've measured these 100 microfarads and they're spot on with a good ESR of about half an ohm, so that's not too bad. It's not a switch mode power supply, is it? They're all marked the negative, and so the capacitors, so not too hard to get them the right way round. So I'll get stuffing them in. Just looking at the supplied coils, I should have a 14 turn, yeah, that looks good. A 4 turn and another 4 turn. Well, I seem to have 2 3 turns, so I don't know if that's been corrected or not, but basically you've got the 4 turns on your aerial input and at the collector of the aerial amplifier, the RF stage. 14 turn, I'm assuming that's some sort of IF block. Stop that getting in. This is a very interesting design. There's even some inductors that isolate parts of the circuit from each other, stopping feedback through the circuit from the IF stages, so that's a nice touch, and loads of decoupling. And so that's interesting. By the way, these inductors can go either way. I've put the diodes in, making sure I've got the right diodes, and that looks a bit on the high side. I'll have to correct that. Making sure I've got the 1N60s in the right place, because if I mix them with the 1N414 I'm going to have some serious problems because they're not designed for RF. So yeah, it's coming along, but just this problem here, because I've got the wrong amount of turns, I'm going to have a problem with the tuning. So I'll have to decide what to do about that. Also, I note that the enamel hasn't been taken off for you, so I'll have to scrape it or burn it off or something. Well, I've made another four turn inductor and put the rest on. There's 3 turn here. Local oscillator runs higher, doesn't it? Spotted something I've done wrong. Silly boy. Whoops. That isn't going to work, is it? I put the pot on the wrong way round. Oh damn, that'll be a pain to remove. Best look at the photographs. Right, that's a bit more like it should be. The silk screen is marked on that side, so, well, there you go. I'm not perfect, I'm human, I make mistakes. Well, put the cores in and look at the photographs, and it does also seem to be corresponding to the translation I did. That one is actually a brown one. That's black. Interesting, the discriminator seems to use 2 cores rather than a core with a tertiary winding on, so that's interesting. Now, I was just thinking, oh, I'm almost finished here. Of course I haven't, because there's an amendment, there's some surface mount components here, and basically you've got to put some neutralising resistor and capacitor on the IF stages. I guess they may have had a problem with it, bursted into oscillation, so that's going to be a bit of fun doing that. Any other notes? No, I think that's about it for now. I'll just try and get on with that. There is some pictures to show the positions. The problem is the circuit diagram that was supplied with this is really very hard to read. I'm a bit disappointed with that. There is some links, download links on this, so perhaps you can download it. But yeah, circuit diagram very, very fuzzy indeed. I can't really read the component values at all, which is a shame. There's the neutralising in the middle of your screen, handheld shot, sorry, not good. But yeah, there we go. There's the resistor and capacitor between the collector and the base. Right, I think I've got my neutralising capacitor and resistor in on all 3 positions. And there's a little bit more of a close-up of the neutralising resistor and capacitor. Just looking at first power up, I think I've set the bias anti-clockwise. I think that's what I've got to do. This one, it seems to be something to do with the bias on the first transistor. I think it may set the centre rail. Something about 150 ohm measure across the left one. 150 ohm left half rail is what the notes I've got, so I don't know if that's right or not, but time for the smoke test. Okay, 9 volts on, about 20 milliamp being drawn, and there is some noise, so yeah, that's a good start. I suppose what I tend to do first is just see if I can just sharpen up the discriminator a bit. It does sound a little distorted, so perhaps we haven't got enough bias, but this seems to have a lot of okay, well, nothing received much yet. I suppose I do a 10.7 alignment, be a good start. Okay, I thought, well, I'll just open the trimmers up a bit on the local oscillator, the trimmers here. Yes. There is signs of life there. Yeah, that's good. Okay, well, that's a good start. I'm just coupling a bit of 10.7 in. Because you've got the way this discriminator works, I've connected a meter on one of the diodes at the centre of this core, thinking, well, it will work as a rectifier. Seems rather broad. Oh, maybe I've bottomed it. That's interesting. Doesn't quite work as I expected. Well, I've been fiddling with this for a while and I'm just thinking, instructions say adjust for the loudest sound, just adjust the trimmers for the loudest sound, so I might just do that. These trimmers do not have a lot of adjustment range, it seems, compared to what I'm used to, so it's very hard for me to seem to completely detune the discriminator in order to get a voltage, so I'm just going to adjust it for the loudest tone and keep turning the level down and just see how it comes out. Well, I've been having a bit of fun here. I've just done exactly what this said, peak for maximum smoke. I must admit, a lot of these trimmers are right near the top. I've been fiddling with the local oscillator inductor and I've stretched it a bit to get 88 a bit closer to the end of the capacitor. The capacitors, trimming capacitors are virtually, the oscillator's virtually open to get 108. The RF oscillator's a little bit back. I trimmed it up at around about 106 megs for maximum sensitivity, and so I can hear most of the stations on it, so it's not working too badly, I guess. So I've just been trying to work out this balance and the bias. Yeah, so if I meter here to ground, that is, you basically adjust this one for half rail, as you can see me doing here. It's 9 volts, so it wants to be about 4.5. As for the bias, that's interesting. I've set it a little bit higher than said. You've got to be a bit careful because this is very, very sensitive. You go too high and the current goes through the roof. But I just set it for sort of best sound quality, really. Just crept it up until I can hear the crossover distortion go. I'm drawing more like 25 milliamps rather than suggest, I think it was 10 to 15. So I will have to go over this and check there's not an issue with the amplifier. But it is working, so that's good stuff. So that's another kit working. So perhaps I'll play some YouTube music for it. twiddle with the bias. Seems to be rather high to get the distortion to go down, but let's turn the volume down. Standing current's about 21 milliamps. Well, that's me done with a couple of kits for the moment. I'm going to put this to one side. I'm going to use this. Needs a box really, but didn't come with one with this version of the kit, but bit of fun. Completely discreet radio, so yeah, that's a bit of fun. Well, I've just picked this up again. It's been sitting in a box for over a year. The problem with this is that I seem to have the bias set higher than I expected. Otherwise, it sounds distorted. And having it at about 40 milliamp bias, what keeps happening is keep getting thermal runaway. Also find that the it's very sensitive to adjust. I managed to sort of cobble a circuit together from the fuzzy diagram and somebody else's YouTube video. So I was just looking at how it's done. It appears that you've got two identical NPN transistors as your output, and they're driven by a complementary pair, otherwise a PNP and an NPN. What I noticed with interest is you've got bias on those two. It's provided by here, that's where your bias is. I've noticed that this transistor has got an emitter resistor of 6.8 ohm, whereas this transistor hasn't got anything, and I'm wondering, because there's no stabilisation resistors in the emitter of this side, that once we hit the bias voltage, this switches on damn hard, and I think that might be what the problem is. I'm not sure. It looks fairly conventional otherwise. You've got feedback from the centre, you've got a capacitor to filter out any audio, and that's connected to the emitter of this transistor. It goes to that transistor, so as that goes off voltage, this is turned on harder or less hard in order to stabilise the voltage in the middle, and I guess that's why there's an adjustment here for the base voltage, so you can zero it. So I'm wondering about putting a 6.8 ohm resistor in there just to see if it makes the bias a little bit less likely to go off on one. That's what I think the problem might be, but I'm just not sure. That's no bias. That's 10 milliamps. That's 20 milliamps. And now we've got about 30 milliamp bias. Well, I think I definitely need to look at this amplifier, don't I? That's the input to the volume control at the top, and that's the output of the amplifier. Look, yeah, something's not right. There is a just experiment at the moment. There's a 12 ohm where the 6.8 was. This is where I cut the emitter connection and inserted a 12 ohm. So I've actually doubled the resistance. What I'm finding now is that the biasing is so much more even on both transistors now. This mod ended up a little bit of a mess because you can see I've had to connect to the transistor and the 150 ohm resistor, and I've cut the track to the emitter, and then of course there's a cut there as well so that the 150 ohm isn't connected on that side. So hopefully that will be right, so that the 150 ohm is on the right side of the 12 ohm, so there's a slight volt drop through it. Well, that's jolly better, isn't it? It's not perfect, but it's damn sight better than it was, and I've only got about 10 milliamps of bias now. hopefully it won't firmly run away. So I've got about 48 millivolts across that emitter resistor, across this one more or less the same. That's good. So that's obviously balancing the load up now, so that both output transistors should be getting a similar amount of bias, so that's why it's obviously working better. I can still get these transistors hot. If I turn the volume up, I'm running on 7.5 volts with a 4 ohm speaker. That is quite a bit for these. I guess I could have put some of these on, some heat sinks to stop it, but it's not firmly running away so much as it was. The biasing is moving, but it isn't going ridiculous, and if there wasn't current limit on here, I think I would have blown the transistors, but there you go. So after this being chucked in a box for a year, at least it sort of works now without the biasing wandering all over the place. So I'm not quite sure what to make of that. I still don't know what to make of the fact that all these are at the top. It's a bit odd. So anyway, thanks for watching. There's the XTD FM Radio Kit. It is interesting on an educational point of view. I will give it that. Being able to see a discriminator, the IF stages, local oscillator, the input buffer and the mixer. So it's certainly interesting in that way.
Slip Road from the 8264, so if you're coming on to the 8... or download an info.
Thanks for watching. I'll see you soon.